Yeah, thanks, Prue. I guess I'm sharing with you here today some very new work, and a lot of it's still in its preliminary stages, but hopefully it's evolved enough to provide you with something. I must, of course, acknowledge my co-author, whose knowledge of the Northern Flinders Ranges and South Australian geology is absolutely superb. And I guess I just want to say it's great when I can get a couple of days to get out of the office and still look at some rocks every now and then. I think it's about the second time I've done it while in this job. Okay, at the Convention Centre, it'd be very easy to give a talk on the Northern Flinders Ranges that just made everyone feel warm and fuzzy about hematite breccias, magmatic systems, and how they're breccia pipes, and that we've got this Mount G epithermal system, we don't know how old it is, and there's tillites in the area. Well, I guess you know a little bit of where I might be heading with that after hearing Neville's excellent presentation, but in the past, a lot of this has been talked about as being Adelaidean. And I could talk about peneplains and land surfaces. That would be just delightful. We'd all be warm and fuzzy and comfortable, but we're not going to do that. What we're going to do is bring together some new insights, and they're actually quite challenging ones. And the suggestion, well, what I'm going to put forward here today, on behalf of Steve Hore and myself, is that a lot of what have been called hematite breccias are in fact indurated altered remnants of Mesozoic sediment, probably from the Cretaceous, of glacial and colluvial origins. We now have a lot more knowledge about the Mount G system, and we're confident that it's from the Paleozoic and again into the Mesozoic. That the Flinders Ranges were not a flat billiard table prior to the Miocene. In fact, in the Mesozoic, there were significant uplands in that area. And here's one that's really interesting to think about. If these things are sedimentary remnants and they occur at near the unconformity in the area, then perhaps we're looking at an unconformity uranium system rather than a hematite breccia pipe magmatic type system. And this has profound implications for other areas in South Australia. Before I do go on about this though, I would like to acknowledge the previous workers. Once a new idea gets seeded, it's absolutely fascinating to go back to the previous work and look at what previous people described in areas that you're now trying to reinterpret. And I would say that in most cases, the previous workers got it right, or there were little bits of the puzzle that they were absolutely spot on, but they weren't blessed with the geochronology or the studies from other people to help them make some of the breakthroughs that I'm talking about today. It's great reading this old work, particularly in the context of new ideas. Where are we talking about? I think we all know where the Northern Flinders Ranges are. In a little bit more detail. The main focus of the talk, as I said, will be on what have been previously called the hematite breccias, the radium ridge breccias, they're also known as. But that of course has a lot more wide and important implications that I'll also be touching on in the presentation. So let's get straight into it. Let's have a look at some of the geological characteristics of these so-called hematite breccias. They actually contain a range of clast lithologies. Those clasts are rounded and angular. There's a real mixture of stuff in there. And very importantly, that they mostly cross-cut basement structures. And they're cemented by hematite and chlorite and typically surrounded by areas of clay and silica alteration. Some of the other things are a wide array of trace elements besides just uranium. Really interesting ones that when people do regional surveys get quite perplexed about. What we have in the area is fantastic 3D mapping continuity with some of the sections that Neville showed, particularly to the east of the ranges near the hot springs and 4 Mile West. These sediments, which I'll now start calling them, are intruded by the youngest of the Mount G epithermal system, the so-called nail hole quartz phase. And Steve's been doing a lot of work on the detrital zircons and pulling out young zircons. We've published some already at 264 million years. A little bit like my co-author, these sediments seem to get younger and younger as we look at more and more zircons, and Steve's now found some that we haven't published yet at about 220. This is a really good example of the so-called hematite breccia, which I'm now trying to refer to as sediments. This is at the number 4 workings, where we see the unconformity, and these large matrix-supported clasts, matrix that is indurated by hematite and chlorite, in this case sitting over the top of Mesoproterozoic granite. In a little bit more detail, that one at the top left there, if that was down at Hallett Cove, you'd be perfectly happy with it being part of a Permian glacial system. These have all the hallmarks of matrix-supported variable lithologies of tillites. We also see some variations. The interesting two on the right there are ones that have been quite confounding in the past, sort of angular, more class-supported types. We're interpreting these as proglacial sediments. They sit at the base of tillites. They have local lithologies and things like that. And there's also rudimentary bedding through them. And we also see lenses of more class-supported conglomerates that are presumably more fluvial. In many places, they're bedded, and quite well bedded, such that we've been able to take a lot of measurements of that bedding. And these are some of the classic so-called hematite breccia uranium prospects that have been looked at in the past that have this bedding through them. There's also associated lacustrine sediments, much of which is chemical in origins, but also detrital. And these typically occur at valley-side concordant benches, which is what you'd expect from a lake sediment fill. The unconformity between these sediments and the underlying bedrock, as I said, cuts across structures and would not be out of place in some of the diagrams that Colin Card showed earlier in this session. This is one of our very favourite ones at the Greenwood prospect. It's only about 5 minutes walk off the ridgetop track, where you can see vein structures, or structures which have veins of pitch blende within them that directly underlie what have been described as hematite breccias, but are in fact hematitic sandstone. The zircon work, this is one that we published a couple of years ago, showing the young zircons at about 260 million years, so this certainly puts the sediment out of the Adelaidean. Just at the very end of the Permian, we feel that it's too young to be part of the more widespread Permian glaciation, and as I said, Steve finding younger zircons still is consistent with that. There's an interesting mix of rounded and angular zircons through here, but a definite prevalence of locally derived zircons. This is from East Painter. And also it's interesting to see this lead loss that's occurred in the Cretaceous. So our age constraints, we think the data that we're building up here is really consistent with us suggesting that this is equivalent to the Livingston tillite that Neville talked about in his previous presentation. So what does that mean? What it means is that some of the traditional models for landscape reconstruction are in need of further thought. And so some of this stuff we can give big red kisses to, good for its time, but if we look at these sediments, we actually see that they mostly correspond to valley drapes. Okay, so these are tillites and colluvial sediment mantles that are draping a Mesozoic Paleo-Valley system. And once you get an eye for that, it really changes the way you start looking at the landscape. Here we see Scylla's Lookout and the Turquoise Prospect. And that ramp that everyone's driven up that's done the ridgetop tour to Scylla's is actually the Mesozoic Paleo-Valley margin, which that margin goes through the Yadnamatna Creek area and then leaves the ranges near the hot springs where that yellow arrow is. So we've got these little remnants that have been mapped out in the past. What we're starting to see and suggest here is that we're looking at a Mesozoic glacial valley system that was broadly moving towards the southeast. A modern analogue, here we see part of Patagonia, where Chris Wilcox went for a holiday a few years ago, and I saw this photo on his computer and I thought, oh my goodness, that could be Arkarula in the Mesozoic. A little bit about the Mount G epithermal system. There's multiple phases of activity there, but there's two main ones that we're seeing quite consistently through the area and are important markers. There's an older one that Steve has recently been able to date some monazites from within at 380 million years. That's new. That's a new result that's soon to be published, so I'm sharing that with you a little bit ahead of schedule here. And then a younger, the famous nail hole quartz, which is after zeolite pseudomorphs, that intrudes that older phase, but also cross-cuts the sediments in this area. So that provides some important age constraints for this system. It also tells us a lot about really the erosional detritus that's being shed from that system as well. Here we see that earlier phase, that hematite-rich 380 million-year-old monazite phase. And here we see that younger nail hole quartzite phase. And you can see in the two right photos there of it intruding these sediments. You put all that together and the wonders continued. And when the penny dropped here, that perhaps what we're looking at then is if we're looking at a lower part of a sedimentary system that's been indurated by hematite and chlorite, this is not at all dissimilar to a lot of the Saskatchewan type descriptions of unconformity uranium systems. Base of sedimentary cover, just world-class exposures of alteration and mineralisation, overlying structural zones, and we've got that important heat source, which has been elusive to many other parts of South Australia. Trace element compositions and these beautiful alteration systems that you can walk around in the field. They're just stunning. Here we can see, haven't got time to go through all of this, but here are some of the sort of popular Saskatchewan models and some of the similarities and differences and questions about the Mount Painter ones. But we're certainly well on the way to seeing some pretty important similarities there. In particular, the alteration that we see, chlorite, hematite, kaolinite zones, and the oxygen isotopes of that kaolinite suggesting that it formed at about 150 degrees Celsius. Make a really, really compelling and interesting story. Silica alteration is really abundant in these areas, but it's been previously mapped as jasper or silcrete in the ranges. But in actual fact, we're looking here at a hydrothermal, epithermal alteration that's associated with these unconformity systems. So just to wrap up, that was all exciting geology stuff, but then it starts to get really interesting when you think about what that might mean for other parts of the state. Okay, so that unconformity system has probably been an important precursor to the later sediment-hosted uranium systems in the Callabonna subbasin, be it from chemical mobilisation, but also very important has been the denudation of the ranges and that removal of that uranium-rich system out onto the plains, and then subsequent chemical remobilisation from there. That sub-Mesozoic unconformity is really important. But if you start looking at the drill holes in the Callabonna subbasin, areas that you think, well, they might be interesting to look at, it's remarkable of how little of that material has been saved or even drilled to. Much of the sedimentary uranium exploration stopped short of it and really only looked at gamma and a few other properties in the sedimentary cover. A lot of the deeper exploration effectively punched through all the altered kaolinitic stuff and went down until it hit hard rock. And so that part of the system has been mostly missed in previous exploration. So it's interesting for us to think about a new mineral system model for this area, what you might need to look for, and where else to look. And we've got a few areas that we think really warrant some further thoughts, particularly to the east of the ranges near Arkaroola Springs, but also a little bit on the western side. It then takes you further, and some of this is not new, and that is that many of our IOCG deposits, such as Olympic Dam, have had a lot of remobilisation and a long history of mineralisation development. And the proximity to these unconformities have probably been quite profoundly important. Not just Mesozoic ones here, perhaps Adelaidean, Permian, and so forth. And similarly, Mount Isa, which is on the margins of the Eromanga Basin. So there's some really new things that have been put together here, changes over 100 years of geological thinking. We've got some of it covered in existing field guides. We're writing it up over summer for a AJES special issue on the Northern Flinders Ranges. We're contemplating putting out the offer of a field trip for interested parties next year sometime. Please let us know if you're interested. It'll be driven by your interest, whether we do that or not. So to wrap it up, Prue's getting fidgety. What I'd like to suggest is that now we look at this landscape in the Flinders Ranges, particularly the Northern Flinders, and we have new ways of seeing it. We see these paleo valley systems from the Mesozoic now. We have them filled with sediment, mostly glacial type sediments. If we look at a section through those sediments, we start to see interaction with the Mount G epithermal and hydrothermal system, providing convection cells within those sediments, and alteration systems around uranium mineralisation. The area has now been uplifted there. You've had oxidation of that mineralisation, you've had chemical and physical removal of it, but the action is still out there under the plains, under the cover, and I think there for us to start looking for and not discarding and ignoring. Thank you very much.